Hello all. Today in this video lecture we will see Varignon's theorem. First we will read this definition and after that I will explain you what is Varignon's theorem. If many coplanar forces are acting on a body, then the algebraic sum of moments of all the forces about a point in the plane of the forces is equal to the moment of their resultant about the same point. So first of all, understand coplanar forces. That means that forces are in one plane. So consider if this is as one plane, if this is one force, this is another force, and this is another force. So are acting on a body. These three forces are in one plane and are acting on a body. Then algebraic sum of this F1, F2, F3 forces moments. If we will consider moment here, then this moment about a point in the plane, this point should be in plane, this O point should be in that plane only, in the plane, is equal to the moment of their resultant. So if this is resultant moment, then this C R into X is equal to summation of all moment. This R into X is nothing but the resultant moment, and summation of moment, that means F1 x1 plus f2 x2 plus f3 x3. So this, if this is x1, if this is x2, if this is x3, like that. So if many coplanar forces are acting on a body, then algebraic sum of moments of all the forces about a point in the plane of the forces is equal to the moment of their resultant about the same point. So this is Varignon's theorem. So note that Varignon's theorem is used to determine a position of resultant in the non-concurrent force system. So what is non-concurrent force system? Non-concurrent force system, that means they should not pass through one point. They should always pass through different point in a single plane. Concurrent force system, that means this concurrent forces always pass through one single point, but non-concurrent forces are not passes through single point. So we will see proof of this Varignon's theorem. Case 1, we will see concurrent force system. So now we will see proof of this Varignon's theorem with the help, like using that concurrent force system. So consider this point as O. So if this force is F1 force, let us consider this as P force, and if this force is Q force. So see here what we saw, that Varignon's theorem is to determine the position of resultant in the non-concurrent force system. But here in concurrent force system also we will see it, like we will see proof of that with the help of concurrent force system. So consider here parallelogram, and if we draw here diagonal, then it is nothing but a resultant. And if I will consider here at point O, see this P, Q and R these three forces are in one plane. These are not, these are like in a single plane, and this O point is also in a single plane. If I will join this and this, let us, if we consider this O, then consider this as A. As A. O. So join OA here and join A. Let us consider this as B and join OB also. And assume this as C and D. So first I will take, so here this is our moment point. At point this O point we will take moment. So take moment at point O. So take P force moment at point O. So we saw in our previous lecture that moment is nothing but the 2 into area of triangle. Area of triangle, that means that triangle makes between that force and where we are taking moment. So 2 into area of triangle OAD. 2 into C. We are interested to take moment here, and now we are taking this P force moment. So this P is this force. So this P and O is making triangle. Which triangle? OAD. 2 into triangle OAD. Now take this Q force movement at point O. 2 into triangle OAB. This Q force is this, and where we are taking moment at point O. So between this Q force AB and O, triangle is OAB. And about resultant, see this resultant is AC force, and we will take moment at point O. So AC and O, so OAC. So take R force, resultant force, moment at point O is equal to 2 into triangle OAC. So first of all, observe here that this is diagonal ABCD. CD, and here this is parallelogram AB CD, and this is diagonal, so this triangle and this triangle will be same. So triangle ADC equal to triangle ACB. ABC. Again, see that this AB is base and this OAB, like that. This OAB and this OACB. So this OAB and this ACB will also same. So triangle OAB equal to, because see here they are like their base is same, that's why they are same, they are ABC. So with the help of this 1 and 2, what we will write? We will write ADC, triangle ADC is equal to triangle ABC is equal to triangle OAB. So from 2 and 3, triangle ADC equal to triangle ABC equal to triangle OAB. Now see here, moment of P at point O plus moment of this Q force, P and Q force, this P and this Q, moment of Q force at point O is equal to, see here, moment of P at point O is 2 into triangle OAD plus OAB Q, moment of Q at point O is 2 into triangle OAB. So what I am try to prove here is moment at point O plus moment of point Q is equal to moment at point R, like moment of R at point O. So here I need these two triangles, this OAB, this OAD plus this OAC, right here, this OAD plus OA, no, OAD one triangle plus this ADC. Then I will get that OAD I have, then thereafter that ACD. See here, OAB here, OAB is equal to ADC. So 2 into triangle OA, so take this 2 common, 2 into triangle OAD plus 2 into triangle ADC. Oh, sorry, this 2 will not come here. OAD, triangle OAD plus triangle ADC. OAD plus ADC here. This OAD plus ADC is nothing but the OAC. And see here, this 2 into triangle OAC is nothing but the 2 into triangle OAC is nothing but the R force moment, this R force moment at point O. So we proved it. See what we prove here with the help of Varignon's theorem. This P force moment at point O plus this Q force moment at point O is equal to this resultant force at point O. So summation of all forces moments at point O is equal to resultant of force at that particular O point in that forces plane. So these always remember that these are coplanar forces. These are in one plane, and where we are taking moment, so this point is also in one plane. So this is Varignon's theorem. So here in a note we wrote as that non-concurrent, like see in our second case we will see this non-concurrent force system. So here I prove it with the help of concurrent force system also, and in next lecture we will see non-concurrent force system. I will prove this Varignon's theorem with the help of non-concurrent force system. So in non-concurrent force system also and in concurrent force system also, we determine position of resultant with the help of this Varignon's theorem. So this Varignon's theorem is nothing but a summation of all moments like at that particular point in a plane of that forces is equal to resultant of that resultant moment. So this is Varignon's theorem. Thank you very much. Hello all. Today in this video lecture we will see proof of Varignon's theorem when two forces parallel to each other. We had seen Varignon's theorem and we had also seen Varignon's theorem in concurrent forces. Now we will see Varignon's theorem in parallel forces. So let us consider this as A point and here this force. Let us consider this force as P and here B point. Let us consider this force as Q. So this P and Q, these two forces are parallel to each other and they are in one plane. This A B point is in one plane only, and if I will draw some perpendicular line here to that A to that PQ forces, let us draw perpendicular line to forces P and Q and let us assume this as O point. O point is also in same plane where that A and B point is. This PQ are coplanar and parallel forces, and you know that resultant of this force will be like this. Sorry. Like this. This is resultant. R is equal to P plus Q, and let us assume this point as C. This C point is also in same plane where A, B and O points are. So let us take moment here at C point. Here at C point. So this P into, let us assume this as, let us notify this as something X, Y and Z. The Z is here to here distance, this X is this distance and Y is this distance. So moment at point C is equal to 0 because see they are balancing each other. This P, let us assume that clockwise movement is positive and anti-clockwise movement is negative. So this C point, see this P forces is passing through that C point as a anti-clockwise. So anti-clockwise is negative. So minus P into X. This Q forces is passing through that C point as a clockwise. So clockwise, that means positive. Force is Q and distance between that C point, perpendicular distance between that C point and force Q is Y equal to 0. This is equation 1. Now next take moment at this O point. Moment at O point equal to 0. See this P force is making clockwise. Pass that P force through that O point, it is making clockwise rotation. So clockwise, that means positive. Force is P and perpendicular distance between O and that force is O, that means point where we are interested to take moment, and that force, perpendicular distance between point O and that force is the Z. So clockwise, that means positive P into Z. And this Q, see this R, take this R also. So So do not take this resultant here while calculating moment at point O. Only consider that P force and Q force. So Q into directly, either it is easy for us to see this X is nothing but this AC. Directly write here as AC because it is easy for us while doing mathematical calculations, and Y is nothing but CB. See this CBAC. So this Z is nothing but this OA. So P into OA plus Q into OB equal to 0. So this OA, P into OA is nothing but see this OC minus AC plus Q into OB. OB is nothing but OC plus CB. Just what we are doing, we are we are proving that this moment of P at point O plus moment of Q at point O is equal to resultant moment at point O. So that's why we are writing as OC plus CV, OC minus AC. We are concluding OC in our derivation. So here just do some mathematical calculation. P into OC minus P into AC plus Q into OC plus Q into CV. So here P plus Q take common and into OC, and here minus P into AC plus Q into CV. So see this P into AC plus Q into CV. See P into AC plus Q into CV minus P into AC plus Q into CV. This whole term. What is this? This is equation 1 and it is 0. So remaining term is only P plus Q into OC, because this is total term is 0. So P plus Q into OC. See here. P plus Q is nothing but a resultant for, and OC is this. Resultant into OC. So see this P into OA plus Q into OB. It is moment at point O equal to resultant. What we derive here, remember that this P force P into OA plus Q into OB is equal to resultant into OC. These things we derive here in this derivation. P into OA plus Q into OB equal to resultant into OC. So this is Varignon's theorem proved with the help of coplanar parallel forces. Thank you very much.